In this video, we are going to take a look at what the first derivative tells us about the graph of a function. In particular, how does it indicate when a function is going to be increasing and when it is decreasing? Right, so let's look and see. So what do we mean by increasing and decreasing when we're talking about functions? Well, function, we say that it is increasing on an interval if for any two numbers, x1 and x2 in the interval, x1 being smaller than x2 implies the function value at x1 is smaller than the function value at x2. So this is telling us as our x values move from left to right, so we're moving from a smaller value to a larger value, the y values are moving from smaller values to larger values. So that is increasing. A function is decreasing on an interval if for any two numbers x1 and x2. If x1 is smaller than x2, then the function value at x1 is larger than the function value at x2. And so this is saying as we move from left to right, as we move from left to right in the x values, our function values are moving from larger to smaller. Right? So as we move left to right, it is going down. So let me draw a picture of a graph here really quickly. And let's say we have something like this. So maybe this is -1. All right, so let's see if we can identify where is this function increasing. Well, it is going to be increasing. It is going up from here up to this point right here. So it's increasing on this interval from -infinity up to -1. At -1, it starts decreasing, and so it's decreasing. The picture is going, that graph is moving down as we go from left to right. As our x values get larger, the y values are getting smaller. Right? And it is decreasing from -1 up to 2. Then right there at 2, it starts to increase again. And it's increasing from 2 all the way up to, it looks like 6 is what I made that. And then after 6, we are decreasing again. And that's what we have. We could then write this as we could say it is increasing on the interval from -infinity to -1, union with 2 to 6, and it is decreasing on -1 to 2, -1 to 2, union together with 6 to infinity. So those are our intervals of increase and intervals of decrease. So when we look at these, we might try to identify what is happening when this function is increasing. What's true of the derivative? And so the derivative, we can think of derivatives as slopes of tangent lines. So it's increasing here. What is the slope like right there? Well, that slope is going to look like this. What's our slope here? Well, that slope would look like that. Is that slope positive or negative? So our slope right there, that has a positive slope. In fact, everywhere where it's increasing, your slopes are all going to have positive slopes. right? Over here, where it was increasing, we have slopes that are all positive. They're all moving up as we go from left to right. And so, this relationship between a function and its derivative is pretty, I think, pretty interesting. Whenever the derivative is greater than 0, so let me back up. So if f is a function that is continuous on a closed interval from a to b and differentiable on the open interval a to b, then if that derivative is greater than 0 for everything in that interval, then our function is increasing on that interval. If instead it is smaller than 0, then the function is decreasing. And if that function value is equal to 0, then it is horizontal. It would be neither increasing nor would it be decreasing. So let's come up with a strategy, or let's talk about a strategy where we could find intervals of increasing and decreasing. Well, really it's going to boil down to looking at the derivative, find where that derivative is 0, and then find where it's positive and negative. So, to find the open intervals on which a function f is increasing or decreasing, we will use the following steps. So our first step is find the critical numbers, also any points of discontinuity. So all the critical numbers and all the points of discontinuity, those are going to help us to determine some test intervals. Then what we want to do is we want to determine the sign of the derivative for a test value in each of the intervals. And then we will use our test from the previous slide to determine whether f is increasing or decreasing. Right, so if our derivative is positive, then it's increasing. If our sign is negative, our derivative is negative, it's decreasing. Right, so let's go through this small example here. We have f of x equals x cubed minus 6x squared. Our derivative here is 3x squared minus 12x. You could factor out a 3x from that and have 3x times x minus 4. What are we going to do with that derivative? Well, we need to locate the critical numbers. So we're going to set it equal to 0. It's going to be equal to 0 when x is 0 or when x is 4. So those are critical numbers. We also need to identify any points of discontinuity. This original function was a polynomial, so it is continuous everywhere. There are no points of discontinuity. And then we are going to determine the signs in each of the intervals. Now, what are the intervals that this defines? Well, starting at negative infinity, we are going to go from negative infinity up to 0. And then we're going to go on the other side of 0 up to 4. And then from 4 up to infinity. And what are we going to do on these intervals? Well, we are going to try to identify what is the sign of the derivative. And to find the sign of the derivative, all you have to do is pick any number in each one of those intervals. So pick any number from negative infinity to 0. So you want to pick negative 1? Great. Let's pick negative 1. So the derivative at negative 1, that derivative at negative 1 is 3 times negative 1 squared minus 12 times negative 1. And we can observe that when you plug something in like that, you will get a positive value. that derivative is larger than 0. Pick something between 0 and 4. I don't know, maybe 2. Plug 2 into your derivative. And if we plug in 2, we're going to find out we get some negative value, something smaller than 0. And plug in something larger than 4 into our derivative. So I don't know, let's say 5. And when you do that, you'll find you get a positive value. And that is our sign chart. That is step 2. Right, so we determined the sign of the derivative at one test value. So we picked -1, 2, and 5. You could have picked -10 billion, 3.75, or you could have picked pi there. Oh, that would have been great. You could have plugged pi in, and you could have picked 28.4. I would pick nice values, but whatever values you want to choose, as long as they're in the intervals. Now, what does that tell us? Well, wherever the derivative was positive, it is increasing. So our function is increasing on the interval from -infinity up to 0, along with, union with, 4 to infinity. And our function is decreasing on 0 to 4. And that's how we can identify whether a function is increasing or decreasing. All right, in our next video, we will look at more examples where we find intervals of increasing and decreasing. We will see you there.